Good morning to one and all. Today we are going to see the operations of the single linked list in this video. In the previous video, we have seen the traversing of the linked list and searching of an element in a linked list and displaying of a linked list in the previous video. In today's video, we are going to see the inserting an element into the linked list. So we can insert the element into the linked list in different ways. Some of the ways that we are having are inserting an element at the beginning of the linked list, inserting an element at the end of the linked list, inserting an element before another element or node, or inserting an element after another element or node. So at first we'll go to the inserting an element at the beginning of the linked list. We'll consider this as an example. For your understanding, I have placed the addresses here. So start is pointing to this particular, initially to this node. Then this is pointing to this node that is present in 200 address. This is pointing to this node that is present in 300 address. This node is pointing to this node which is present at 400, a memory location. Now we are creating a new node. Consider this is the new node that we are having. Now in this algorithm, what we want to do is we want to insert an element before 10. That is at the starting of the linked list. So now start is being pointed to this particular 10 value. Now we want to point to the node that is having with 5 value. And this is the start and this is the new node. So initially what we are doing was new node of next is being pointed to this particular start. That means now 5 is pointing to this particular 10. So that is 100 has been placed here. And then start previously which is pointing to this particular node. Now it is pointing to this particular 5 value. That means we are doing two operations here. One is new node of next is pointing to the start and the start is pointing to the new node. So this is the algorithm that we have written. We are creating the new node and the new node of next is pointing to the start and start is nothing but now the new node. Now before writing this particular program for this function, we see how to create a new node. Because this is repetitive process in every part of the insertion, I am writing it separately. I am asking to enter the data to insert and I am reading the number value. Then by using the mlog function, I am creating the memory for the new node. And in that new node data part, I am placing the number that I have read, and in the new node next, we are placing the null. This is the function that we are writing for creating a new node. Now we'll see how to write the code for this function of inserting a node at beginning of the linked list. Now I am creating a new node, that is I am getting that particular new node. The step 1 of our algorithm is creating the new node. We have created that one. Then the new node next is being pointed to the start. And the third part of our algorithm is start is pointing to the new node. So this is the function for inserting an element at starting. Now we'll see inserting an element at the end of the linked list. If you see this one, how to go to the ending of the linked list, that was our problem. So because our pointer, that is beginning of the linked list, is pointed by the start, now I want another pointer which is pointing to the ending of the linked list. For that purpose, what I am doing was, initially I am starting at this start. That means my pointer is starting at this start. And I am checking is pointer of next is equal to null or not. If it is equal to null, then this will be the last node of the linked list. But it is not equivalent to null because the start of next is 20. That means another node is there. That's why this is not the last node. So I am going to the PTR equal to PTR of next. If this is the PTR, this is PTR of next. Now the PTR is 20. Is PTR of next is equivalent to null? No, it is not equivalent to null. So PTR is going to the PTR of next. Now PTR is pointing to the node 30. Is PTR of next is equal to null? No, it is not equivalent to null. So pointer is going to the pointer of next. Now this is the pointer that we are having. Now is the pointer of next is equivalent to null? Yes, it is equivalent to null because there was no other node that was present here. So this will be the last node. That means when we want to go to the last node, the concept that we are having was PTR is starting at start, and until PTR is not equivalent to null, the pointer is going to the next node, that is pointer equal to pointer of next. Like this, we came to the end of the linked list that is pointing to the 40. Now I have created the new node called as 50. So this is the new node and this is the pointer. What I want to do for the last node, I want to add this particular new node. Previously pointer of next is pointing to the null. Now pointer of next will be pointing to the new node. That is the code that we are having was pointer of next will be pointing to the new node. So if you see the algorithm, pointer is starting at start. What we have done, pointer is starting at this particular start. Then we are repeating the step 4 until pointer of next is not equivalent to null. That means pointer equal to pointer of next. That we have seen in the diagram. Pointer is incremented from here to here, from here to here, from here to here until pointer of next is equivalent to null. That means until pointer of next is not equivalent to null, every time the pointer is going to the pointer of next. So we are repeating the step 4 while the pointer of next is not equivalent to null. Whenever the pointer of next is equal to null, we are coming out. When we are coming out, what is the thing that we are doing? Pointer of next will be pointing to the new node. That's what we have done here. This is the step that we are having. The step 3 and 4 are the ones that are used in our algorithms to go to the last node of the linked list. Then how we are writing this function? See here, I am taking the new node and pointer and I am creating the new node initially by using the getNode function. Then our pointer is starting at start, and while PTR of next is not equivalent to null, the pointer is incremented to the next node. And at the end, pointer of next will be pointing to the new node. This is the code that we are having for the inserting a node at the ending of the linked list. Now we'll go to the third type of insertion. We want to insert a node before a particular node. We'll see a detailed example at first, then we'll come to this particular code. So in this example, suppose consider that this is the linked list that we are having. So in this linked list, I want to insert an element called as 9 before 4. That means before 4. That is between 3 and 4, I want to insert the 9. In this diagram, I want to find out where the 4 is there. So I am starting at this particular pointer called as a start. Now I am checking, is this node is equivalent to 4? No, it is having the value 1. So it is not a 4. So pointer is incremented to the pointer of next. Then is it equivalent to 4? No. I am going to the next node called as 3. And is it equivalent to 4? No. I am going to the next node called as 4. Now is it equivalent to 4? Yes, it is equivalent to 4. That means pointer is coming here at the end of this process. But if the pointer is present here, I want to know what is the pre-pointer that we are having. That means I need the previous node also. That's why I am taking another pointer called as pre-pointer. This pre-pointer is used to specify what is the previous node of this particular pointer. Now if you see, initially start is pointing here like this up to third value we came. Now is it equivalent to 4? No, I am going to this one. When pointer is going to this one, pre-pointer is coming to the previous node. Like this in our example, pointer is present at 4 and pre-pointer is present at 3. Now in this middle, I want to insert that particular node. What are the operations that we are seeing? See here, This is the pre-pointer, this is the pointer, this is the new node. What are the links that we have to establish is new node of next is pointing to the pointer, pre-pointer of next is pointing to the new node. So this is the way in which it will be converting. Now if you see this particular process, see here in detail I have taken the example. Now as a part of this one, now suppose consider that this 50 is inserting before this 30. This is the link that I have to cut. For this purpose, what I am doing, this is pre-pointer, this is pointer, this is new node. So what I am doing initially, new node of next is pointing to pointer and pre-pointer of next is pointing to new node. What are the two operations that we are performing? New node of next is pointing to the pointer. This is the link that we have established. And pre-pointer of the next is pointing to the new node. This is the link that we are placing here. So now we'll see the algorithm for inserting a node before a particular node. Initially we are creating the new node. In the example we have taken this as a 9. We want to read the value before which we want to insert an element. It is the 9 in our example, 4 in our example, and we are starting the pointer at the starting and we are repeating the steps 4 and 5 until the PTR of data is equivalent to value. While PTR of data is not equivalent to value, we are performing these two steps. What are the two steps is pointer is placed to the next node and the previous node is pointed by the pre-pointer. That is pre-pointer equal to pointer and pointer equal to pointer of next. Whenever in this process the pointer is equivalent to the null, we are displaying the element cannot be inserted. Why we are writing this condition is, if we take in our example, when we are implementing the insertion, if that element is not present before which you are asking to insert, in such cases we are writing if PTR is equivalent to the null, then we are displaying that element is not found. As an example, in this example, they are asking us to insert before 10. The 9 is asked to insert before 10. Is the 10 is there? 10 is not there. So we have to tell that element is not found. For that particular purpose, whenever in this traversing process, whenever the pointer is equivalent to the null, you are telling that the element is not present. That is, we cannot insert the element. Whenever the PTR of data is equivalent to the value, I am placing in the middle that particular thing. That is new node of next equal to PTR and pre-PTR of next equal to new node. This is the process in which we are inserting. Now we will see the code for this particular thing. I have taken pointer, pre-pointer and the new node. I am creating the new node and I am asking the value to insert and I am checking whether the PTR of data is not equivalent to value. If it is not equivalent to value, I am going forward, and if the element is not present, I am displaying this one, then I am performing our two steps. Next type of insertion is inserting an element at a particular after a particular node in the linked list. So in the previous example we have inserted before, now I am inserting after. Now suppose consider that after 20 they are asking to insert 50. Like a previous thing, I am finding out whether PTR is starting at 10 and I am finding out is it 20. No, it is not 20. So pointer is going to the pointer of next. That is, now this is the pointer. Is the pointer of data is equivalent to 20? Yes, pointer of data is equivalent to 20. Whenever it is equivalent to 20, I am placing after this element. See here, if this is the pointer, this is the pointer of next. Now pointer of a new node of next is pointing to the pointer of next and pointer of next is pointing to the new node. Always we have to place left side first, then we have to go for the right hand side. Now we'll see the algorithm for this one. We are creating the new node and we are reading the value, after which we have to insert. The pointer is starting at the start and until the pointer data is reached, I am incrementing the pointer to the pointer of next. In the middle, if the pointer value is null, that means the element is not found. Whenever the pointer of data is equivalent to the value, I am placing that with these two steps. New node of next equal to pointer of next equal to new node. So this is about the insertion.